Okay, good. Hello, everyone, and good morning. It is the final day of DevSpace, and I know that all of you have been working non-stop. So for those of you who were a part of our hackathon, I hope you guys are done with your submissions on HackerEarth and that your efforts come to fruition. Everyone who has tuned in for today's talk, make sure you go and check out our Instagram handle at CSIVITU, where you can find a short quiz based on what Mr. Anirudh will be providing us today on his keynote. My name is Navmi Shivrinda, and it is with great pleasure that I welcome you all. The past decade has seen understanding intelligent machines come to play a role in nearly every industry. Today, we will be delving into the intricacies behind machine learning and data science. Feel free to ask any questions that you might have in the chats. We are excited for you guys to meet one of our keynote speakers, Mr. Anirudh Muralidhar, a data scientist from eBay at San Jose, California. Mr. Anirudh Muralidhar works with the traffic engineering team to derive insights on eBay's traffic pattern. He has been active in the field of advanced analytics and machine learning since 2014 and has played a key role in companies such as Mobius, Lands' End, and Foot Locker. He believes that the future will be driven by big data and that data science is integral in solving multiple problems. During his leisure time, you can find him capturing the world through his camera lenses. He also has a penchant for literature and music and has a monthly magazine by the name Welby. Through his session, he will be discussing the essence, application, and evolution of machine learning over time. Join us in welcoming Mr. Anirudh Muralidhar.
Thanks, Naomi. Pleasure, guys. Are you guys able to hear me? Am I fine with regards to the audio? Just to make sure.
Yeah, we can hear you.
Yeah, cool. So let me share my screen and then let's get started. So yes, thanks guys. Thanks Naomi for the introduction. Like currently I work as a data scientist at eBay. So as she said, so I kind of like try to derive insights out of the traffic pattern. So let's say, for example, if you think about eBay, so there are like billions of requests on any particular given day and millions of requests at a given particular minute. So like, making sure we derive insights out of these data really helps to drive the business forward with regards to like, proper revenue generation, making sure we provide the appropriate recommendation to the user and making sure like the site is run up and running always with regards to performance as well. So with regards to this particular presentation, like it's going to be like page 1 of machine learning, more with regards to like introduction to machine learning, and then like how you could get started with the skill sets needed. Okay, so as table of contents, like what we will be doing is like we'll be having an informal introduction to machine learning, followed by a formal introduction, and then like a simple use case of how machine learning can really help achieve, let's say, for example, a tea seller like Joseph, which we are going to see. And then like what are the real world applications of machine learning? And then like what are the various types associated with it? And then like more of like a philosophy with regards to machine learning, in trying to understand how machine learning has come from the past, right from the caveman time of things. Okay, so and then like how things are in the current era. And then like finally, what are the core skill sets that a data scientist has to have in order to excel in this particular field. Like, given if time permits, I'll also go through one of my projects during my university time so that you guys could have an understanding of how things are being done in order to make like a successful prediction or like, successfully mining insights out of a given particular data set. So let's start with this particular slide. Okay, what do you think makes lion a lion? Okay, when I show these kind of like pictures to you guys, you definitely see, okay, even if I didn't have the title, okay, this is a line. These are like 5 different pictures of line. Let's say like in one particular case, it's a black and white image. One particular case, it's a male versus female. So you are able to kind of like understand it, okay? Your mind quickly processes it. But let's say, for example, if I show the same picture to a 2-year-old or a 1-year-old, okay, so he doesn't see this as a line. For him, it's just like another picture, okay? So what differentiate him versus like the kid versus you is like, you have kind of like seen this a lot again and again. So you're able to pick up on certain futures to kind of like understand, okay, this image is a particular image of a lion, this particular image is of a tiger, and so on and so forth. So when you really think about this particular question, you can tend to kind of like understand, okay, probably is it the eyes? Is it the mane of the line? Is it the weight? Is it the size, the roar of the line? So all these things are like key differentiating factors, which are like unique with regards to a particular line. So every other animal has their own features as well, right? So this is the core fundamental of machine learning as well. So we try to take like key features out of the data set and try to make the decision. In this particular case, given a particular image, is it a lion or like is it of some other animal or not? That's the final decision that we made. And then like we made the decision based out of like certain features. Okay. So with that kind of like a note, like an informal introduction to machine learning, let's go to like an official introduction to machine learning. Okay. So in the past, like specifically like last 30 to 40 years, there has been like a tremendous research done in the field of machine learning, especially like, not only with regards to like the algorithms and stuff. When the computers started to come in, like the software and hardware suppose as those things kind of like boomed as well. That's when like the true capability of machine learning took off, is what I would say. Okay. And specifically at this current time, you could see like a lot more companies, a lot more researchers are emphasizing the need to make like data driven decisions. So every company runs with this particular mantra. So like, with regards to the official definition, I'm going to pick the definition of Professor Tom Mitchell, who is a professor at Carnegie Mellon University. Let me read out this definition. Okay, a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improves with experience E. Okay, that might sound confusing. We will kind of like see an application so that which will help you to understand like what exactly he's trying to say. But in simple words, all he's trying to say is, okay, so we have certain set of experiences, we have certain set of data that we collect, how we could kind of like come up with complex rule engines to make successful decisions. So when you apply these things, probably you might want to improve a business. Probably you might want to apply it to a health industry to diagnose cancer or even like COVID. Okay, so that's what he's really trying to say with regards to that particular definition. We'll come back to this definition again. So let us go to another use case. So let's take an example. Okay, we have a tea seller by the name Joseph. Okay, so Joseph is a tea seller. He puts his tea stall in the nearby cricket ground. Okay, so one day he kind of like wanted to maximize his profit margin. He kind of like attended few machine learning seminars, and then he decided to leverage data and machine learning to make things much more positive when it comes to his business. Okay, so one viable option for him is to kind of like open his tea stall only when a cricket match is going in his nearby neighborhood. Okay, so in order to do that, what he decides is, okay, he decides to collect data. That's the first step of machine learning. You derive insights out of data, right? So he wanted to collect data. Let's say, for example, okay, so I need to understand whether these kids are going to come and play cricket or not. So what are the factors that I could collect as a tea seller? Probably he started noting like the date in which it happens, and then like he checks the wind condition. Is it too high? Is the wind low? Is it raining or not raining? The number of kids that show up to play. Is it a weekend or not? And then like you could think of several other futures as well, right? Is it kind of like an exam time? Is it a holiday season? Probably is it Christmas time or like a Diwali time or something? And then like finally, based upon these kind of things, he has a column which says, okay, at this particular day, these were the conditions, and then like the kids did not show up to play. On this day, these were the conditions, and then like the kids show up to play. So let's say, for example, as you keep on collecting these sort of data, let's say, for example, Joseph collects this particular data set for the last 3 months or 6 months. So now he has like a good enough data to go and understand the pattern, right? So what he kind of like tries to do is, let's say, for example, he applies machine learning, okay, out of some black box or something, and comes up with complex rule engines, okay? So based out of those rule engines, he can like, let's say, for example, a sample rules could be cricket is never played by these kids whenever there is a rain that's happening. Okay. Cricket is always played during the weekends. And then like other rules could be, okay, it's good, it's not raining, but the wind is too high. So again, the kids are not showing up to play for cricket. So by this way, like what he's really trying to do is, okay, so he's trying to kind of like put up his tea stall only when the matches are happening. So by that way, he doesn't waste his resources on like, making tea and other stuffs, okay, for sell, so that it doesn't get wasted for him. And then like the other thing is he could also optimize the other way. he could necessarily fulfill the demand depending upon like the number of kids that show up to play and all those other stuff. So this could be kind of like a real simple machine learning example to drive a particular business. Okay, so now let's just go back to like Professor Tom Mitchell's definition. Let me read it again, and then let's relate this to that particular example. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance as task and T as measured by P improves with experience E. So in this particular case, now you could relate. So let's say, for example, the experience E that he is talking here is about like the data that you collect. For example, in this particular case, the experience could be like, what was the wind condition? What was the rain condition? How many players showed up? Is it a weekend or not? What time of the day is it? And then like so many other futures that you could think of. So these are the experiences that you collect with regards to this particular problem that you are trying to solve. And then like the task, the classes in this particular case is the decision that you're going to make. In this case, the decision is just simple. Is it going to be like a play on or off? So we call this as like a binary classifier when it comes to like machine learning terms. So that's the task that you decide. Okay, so now you have the model being built as well. You need to measure its performance as well, right? Because you could kind of like come up with a really simple rule engine. If it doesn't work, it's not going to add value towards business, right? So you need to have a way to measure the business, sorry, they measure the model in some sort of way. So in this particular case, we could just have like an accuracy as a measure of success. Let's say, for example, if tomorrow, if this particular rule is going to be applied, okay, how accurate Joseph's prediction is with regards to kids are going to show up to play or not, and then like making sure his business is driven according to that. So that's what the definition, the formal definition of machine learning is all about. Like you have certain set of experiences, which is the data, the set of futures that you try to analyze. So the previous example, the line example, you might have futures such as like what's the line of the animal, sorry, what's the weight of the animal, what's the color of the eye, what's the shape of its eye, and then like what's the difference between like the female versus male with regards to the weight, the size, and all the other things. Okay, so based upon those, you have the task T. So which in this particular case, is it a line or not? In this particular case, is the game on or not? And then like how accurately you measure. So it's going to be like with regards to the performance. Okay, any machine learning has these components to it: experience, task, and then like the performance. Okay, so with this particular case, he was able to generate rules, and then like he was able to successfully drive his business forward. This is an example of like a small scale application of machine learning. When you look at like industry level applications, I just quoted like few of the key applications that you would relate to. Let's say, for example, like the Facebook friend recommendation. So every time you open Facebook, you could see like, hey, you might know these people. Okay, so probably you might have experienced this like, okay, so I don't even know this guy. I have no idea why Facebook is recommending him to me. Okay, so in this particular case, you could kind of like see the algorithm kind of like it's not accurate 100%. Probably they have an accuracy of 96 or 97%. So that's why like the error factor comes in. But still like, the recommendation system uses machine learning in the back end. And then like the other sorts of recommendation that you could think of, like an item recommendation, when you're on sites such as like eBay or Amazon, when you go to an item page, you have like people who bought this also bought this. People who viewed this also viewed this. So these are again like few of the applications of machine learning that you could relate to so as to understand how it's being used to drive business. Okay, and then like the other examples like the classic YouTube recommendation as well, Netflix recommendation. So those are few of the things that you could think when it comes to like recommendation systems. And then like the other interesting application is, let's say, for example, redesigning a grocery store. Okay, or to kind of like promote grocery items. Let's say, for example, like every grocery store, we have like a lot of transaction made on a given particular day, right? Based upon those set of transaction, we could mine patterns. Let's say, for example, like there are like algorithms such as like association rule mining or what we call as like market basket analysis. So the key is to kind of like try to see, let's say, for example, whenever a customer buys bread, he also buys milk. Okay, so with a probability or like, let's say a lift score of 1.2 or like a probability score of 0.8 or something, which means there's a strong correlation between buying bread and then like buying milk. So as a grocery store designer, what I could kind of like do when it comes to marketing and stuff, so I could place these two items as far as possible. So which means like, let's say if someone is going to buy milk, so I kind of like estimate, okay, with a probability of 80%, he is going to reach out to bread as well. So in the between sections that he's going to walk, I could kind of like have some items for my own promotion. Probably a new product might have come in the grocery store. I might want to place it in strategic locations so that the customers could be influenced to a certain extent with regards to buying these products as well. That's a classic example of using the association rule to kind of like drive business. And the other example, like self-driving cars. So, self-driving car are becoming a huge thing, especially in California, Silicon Valley. So I'm seeing like a lot of startups trying to solve this particular problem. So, they try to see like how the other surrounding vehicles are performing at a given particular road, how to kind of like see whether the traffic light is green, red, yellow, and making sure like the pedestrians are crossing or not. Suddenly you might have some animal crossing. So you need to kind of like make sure like the car, like in this case, a machine learning model is kind of like equipped to handle all these conditions, right? So because in this particular case, there isn't room for any error as well. So they have to kind of like come up with models with such high precision and recall for them to avoid any such errors. Okay, so other few examples like medical is another huge industrial application when it comes to like machine learning. So based upon like certain futures, so previously we saw about line, right? So now in this case, with regards to medical terms, so like, people could collect futures with regards to one's health condition and try to diagnose with regards to, let's say, cancer, COVID, or any other thing that you could think of, just as a kind of like a first step when it comes to like diagnosis. So you could see like the diagnosis is going to be a lot more faster and then like as much accurate as possible. So that's the whole idea about applying machine learning in the case of health industry as well. And then like few other examples would be like email marketing. So you might have enrolled or subscribed in many of the products that you like. So they wanted to send out some marketing emails or something, right, for their own campaign. So in order for them to target like specific product to specific set of users, they again use machine learning to really understand, okay, what's the favorite category of a given particular customer, how we could kind of like target like specific push notifications based upon his interest. So this is kind of like close to what I do at eBay to a certain extent. Since I work at the traffic engineering team, I have an idea about like what exactly the users are viewing in real time. Okay, so given particular user, how his page flow is. For example, how many users kind of like land on the home page, they go on to the search page, and then they just drop out. Okay, how many users successfully go on to make checkouts? Okay, so now you kind of like keep asking like various interesting questions. If let's say, for example, 60% of users are dropping on the view item page, okay, why they kind of like dropped out of the site versus not doing the checkout? So that's where like guys like us come in, trying to understand, okay, what exactly might be the reason why people kind of like churn or people kind of like not converting it to checkout, so as to kind of like see how we could make this better so that like the users could benefit more with regards to eBay site, as well as like with regards to eBay side of things, how we could drive revenue a lot more, and then like make sure like the customer satisfaction is always up. So these are like few of the key applications of machine learning in real time, and then like in industry that you could relate to. And then like the other most interesting thing is like what we have to understand is machine learning is not something new to us. Okay. Think about like a caveman, like millions of years ago, probably let's say, for example, if he saw a lion at a particular location, okay, at a particular time of the day, and then if he starts seeing the same lion there at the same time and the same location again and again for 10 days, okay, then he might start to decide, okay, so let me avoid going there at this particular time of the day, because like I don't want to have an unnecessary fight with regards with the lion, or like in general like any other animals. So as to avoid danger, he kind of like tuned his own mind, right? The same kind of like happens even today. Let's say, for example, we each one of us are a machine learning model by our own self. Okay, not only human beings, like any living being that you could think, it is a machine learning model to a certain extent. Like even the neural network, all these things, they are kind of like took inspiration from how the brain works, right? So that's why they have this term as neural as well. Okay, so machine learning is something not new to us. That's something that we have to understand. It's always been there within our blood as well. Okay, so and then like think about like an example, like trying to learn like a bicycle or something. You did not learn it successfully in the first go. You tried, you kind of like failed, you fell down, but yeah, as you kept practicing, you tend to kind of like get it better at it. So it's kind of like an optimization problem. The more you do, the better you get. So the more you practice, the more experience that you get better at the task in your hand, right? You kind of like do it with like a better performance as well. So that's the whole intent about machine learning. So we have data, we are trying to derive useful insights out of it, and then like we are trying to make the business move forward with regards to that. Like the whole of human evaluation is in the same terms as well. So we saw something, we kind of like learn from it, we try to see how we could improve. That's how our whole life is structured as well. That's how the evaluation has been. That's how we are trying to do with machines as well. We are trying to make it better using data. So, and then like, with regards to the evaluation of computers and hardware and software, we are trying to take it to the next scale as well. So with that being said, like let's just try to get a bit more technical. Let's see like what are the types of machine learning that is available, or like or that are being generally classified. So any algorithm, let's say most of like 99% of the algorithms that are with regards to machine learning falls in one of these category. So one is like the supervised learning, other one is like the unsupervised. So the other one is like reinforcement learning, and then like you have like several of the data mining algorithms as well. So let's just go into each one of them. So we will be specifically spending a lot more time when it comes to like the supervised learning and the unsupervised learning. So supervised learning is something like, you're trying to learn from an experience. So which in this case could be anything, whether a given particular image is a lion or not, like, text classification, image classification, and then like working with numerical or categorical data. But you have the desired output, what you're going to classify. Okay, let's say, for example, is this email a spam or not? Okay, so then in order to solve this particular problem, you keep on collecting data with regards to that particular task, and then you already have the output as well. Is it a spam or not? So now once you kind of like come up with certain set of rules, okay, when these conditions meet, this email is going to be classified as a spam. When these conditions meet, this email is going to be classified as not a spam. So based on that particular factor, you put in that rule in production, and then like tomorrow when a new email comes in, it has to pass this rule. Okay, if it successfully passes, it is not going to be a spam. If it didn't pass, it's going to be classified as a spam. Okay, that's what like the supervised learning is. You have something to supervise from. Okay, in this particular case, the output itself. And then like this particular supervised learning can be classified into two types further. One is with regards to classification, other is regression. So the difference between classification and regression is quite simple at a high level. One has like discrete output as values. Let's say, for example, lion or not. Let's say, for example, given particular picture, is it classifying the type of, let's say, for example, what kind of flower is it? Okay, so you could think of like there are going to be only certain set of flower types, right? Or like, certain set of emails, or certain set of email types, or like a customer segment type. Okay, so, but when it comes to regression, the output is going to be of like a numerical type. Let's say, for example, you want to predict the house price at a given particular location. Okay, it's not going to be like $1 or $10, right? It's going to be in numbers, and then it can take any value within a particular range, right? So that's what differentiate classification versus regression problem. So classification is just going to be more of like when the output has like discrete values, whether it can be for like an image, text, or numerical or categorical values. The same applies to regression, except like the output value is going to have like numerical values, numerical entries in them, predicting the house price, salary predictions, and like a lot others that you could think of. And then like when it comes to like the unsupervised learning, it's same as supervised, except like, there is no any output decide value. What it means is, let's say, for example, you could think of like you have certain set of data, you're just asked to logically group them together. Okay, let's say, for example, generating like a customer segments, or like, grouping players based upon their performances. When it comes to, let's say, let's take a particular example. Okay, let's take like grouping players based upon like their performances. Okay, so let's take a particular tournament is happening, a World Cup. Okay, you have like, let's say, hundreds of players participating in them, and then like during each game, you kind of like measure some key metrics with regards to a particular player for success. Okay, you measure like how fast they ran, and then like probably how much they contributed to the team, and a lot more others that you could think of. Okay, based upon this, in this particular case, you don't have like a target output, right? So you don't have like, let's say, for example, is this player gonna deliver today or not? Is this player gonna outperform someone else or not? So there isn't any of such use cases in there. You just have their performance metric taken over a period of time. Now all you're trying to do is like cluster them. Okay, you're just trying to logically group them. So that's what like clustering is. So clustering kind of like comes under the unsupervised learning. So when it comes to clustering, there are several ways that you could cluster the data. So let's say, for example, you could use measures like Euclidean distance, like in a L1, L2 norm. Those are like the few of the algorithms that we have. And then like you could kind of like cluster them hierarchically. So with regards to this particular thing, you're just trying to logically group them and try to derive insights out of the data that we have in place. And then like going back to the other few things, let's say with regards to reinforcement. So it's more about like having an agent interact with the environment. You could think of like, let's say, for example, like a chess engine. Okay, chess is something, like a lot of grandmasters play. So, but when machines play, they kind of like, in fact, even in current world, machines are superior, even like when compared to like the superior grandmasters that we have, like let's say Magnus Carlsen or Vishy Ananda, a few of those guys. Okay, so the reason why computer has surpassed, because obviously they kind of like learn from millions of games from the past, and also they have like an agent. They kind of like see at a given particular situation, they assess the environment, and then like they make the move which seems to give us them the best reward that they have that they could make off. Okay, so by this way is how reinforcement learning differentiates itself from supervised and unsupervised learning, and then like they make contributions with regards to like certain set of problems that we have, like a chess engine, or trying to see like how we could use predictor anomalies better. In this case, like we use it in eBay in one of our applications by another team. And then like finally we have like a few of the data mining algorithms. So like let's say for example like the market basket analysis that I discussed before is kind of like a classical example of what falls under like the data mining algorithms. So the whole idea is to kind of like mine insights out of the data that we have. So you're not trying to make any predictions or logically group the data that you have, but it's more about, let's say for example, based upon like the transaction data that we had, what's the relation between, let's say, bread and then like milk, or let's say water bottles versus, let's say, like cookies. So based upon these, you tend to drive the business forward for specific needs. Okay, that's more about like the data mining algorithms and reinforcement learning. But majority of the machine learning problems that are being currently solved in industry falls under like the supervised and unsupervised learning. So that's how like things are primarily in the industry. So and then like coming back to just going a bit more deeper with regards to like the technical aspect of things. So what are the steps in building a machine learning model? Okay, obviously like the first step is to collect data. Okay, so you need to establish data pipeline to make sure like the data is being collected from users interaction. Let's say for example at eBay, whenever you make an interaction with the site or like the mobile app, we can like log as much as possible. Let's say for example how much you tried to click, and then like what are the places that you clicked. Let's say for example a given particular user, how many times he has swiped the image, how many times he has viewed an item at a given particular session, and so on and so forth. Like you could think of like anything that you could think of, all these big giants, they kind of like try to keep track of, like in whatever way possible, with regards to fulfilling like the ethical aspect of things as well. And then like once you have enough data, then depending upon like the problem that you're trying to solve, you have to make sure like you process the data. So which involves like data cleaning, handling missing values, and then like making sure like the data is of appropriate scale. So there are like tons of other things that happens in this particular phase of model building. So in fact, from my personal experience, like most of the time, like most of the heavy lifting are done in the first two phases of the model building. Okay, so building the machine learning model is just kind of like one step with regards to getting it successfully running, but most of the steps is a lot more important than building the model in itself. Okay, so once you have the necessary processing being done, once you're done with the cleaning and then like pre-processing, so the next step is more with regards to future engineering and future selection. Okay, so for a given particular problem, you might collect like hundreds and thousands of futures, but you might not need all of them. Okay, and also you have to consider have a trade-off between like the futures that you select and then like the compute time as well, right? Let's say for example for certain use cases you can't let the model train itself for, let's say for example, more than an hour or even more than a day or something. You might want to make sure like the model is trained sufficiently quicker so that you could kind of like push it to production, so that like the particular application or the particular value is being added towards business on that particular case. So in this cases, like we need to make sure like proper future selection are being done, and then like future engineering is being done appropriately. So what we mean by future engineering is like, let's say for example, when you have like two or more futures. In the previous example, what we saw was like rain and then like wind as two separate columns, right? So let's say, for example, like if we want to optimize this further, can we combine rain and wind to, let's say, one particular future, like let's say like weather conditions or something? Okay, so in this particular case, what we did was we just reduced the complexity of the data that we have, right? So that's what future engineering is all about, trying to understand the futures better and make sure we could do the needed optimization even before like the model building stage itself. And then like the similar process is what future selection is. Let's say, for example, you have like hundreds and thousands of futures. Can you just select like the top best futures? So there are various ways in which you could do this. Let's say you could apply statistics in these particular cases. For example, like a chi-square statistic is something that we use to kind of like select the top 10 futures or top 20 futures out of like the 100 futures. So now when you build the final model, you need not build it using like the top 100 futures. Rather than you just use the 20 futures to get it done, so that it's a lot more less complex when compared to like building with the 100 futures, right? So and then like after you're done with these processes where you go with the model building step. So this involves like making sure you evaluate several algorithms. Let's say, for example, a given particular use case, you could choose algorithms like decision tree, random forest, a neural network, or a logistic regression, and so on and so forth. Okay, and then like make sure you try to evaluate all these models, and then you have a trade-off between each one of them. So that's why you need to properly apply a hyper tuning parameter, because each model has its own parameter for it to be tuned. Let's say, for example, a decision tree might involve like using the depth, a random forest like number of estimators that you could have in order to successfully build an effective model. So you need to make sure like properly these parameters are being tuned so as to kind of like get a model with high success rate. So that's where like you have the model evaluation aspect of things where, so we saw the performance, right, from the official definition. So that particular performance is going to be measured while we build the model using, like, say, like a cross validation set. So based upon it, you have an estimated idea. Okay, so this particular model, when we built like this, we got an accuracy of, let's say, 90%. We got a precision of, let's say, 0.9%, zero point 0.9 or something. So once you kind of like gain enough confidence or like, enough satisfaction with regards to building this particular model, and then like based upon its evaluation criteria, then you could deploy to production and run on the test set. Okay, so build all the models. From tomorrow, I'm going to make predictions. So any request that comes to a site, it is going to pass through this particular rule engine to make a certain set of decision. Let's say, for example, like in industry, one of the current applications that we use for is like a bot detection. So as company, we don't want to serve requests to bots. Let's say, for example, you could write a script which could go and scrape ebay.com. Okay, but ideally from our standpoint of view, we are not serving the end user. So we are just wasting a resource from our side in just serving a bot. So how we could kind of like identify whether a given particular request is a bot or not. Okay, so based upon once we kind of like build a model, so we have the decision to make, okay, is this particular request a bot or not? So from tomorrow, let's say, for example, once we successfully deployed it today, so if a request is being made to ebay.com, we would evaluate it first. It has to pass this particular rule engine, and then like it has to be pretty quick in making the decision as well. Okay, so once it passes, then we serve the request. Let's say, for example, if we kind of like mark this particular request as bot, then we could straight away say send some like dummy page or something in making sure we are not serving the request of this particular page. Or we could send a captcha so that like the user and from the client side could kind of like affirm that, hey, we are not a bot, we are just an actual user, so that we are serving a request only to genuine users. So that's how like a final model runs in production. So, and then like with regards to the current era of big data and computers, if you see, means like we saw right from the Cayman examples, and then like each one of us individually are a machine learning model by ourselves. Okay, but why there's a sudden surge in like, with regards to data science and then like trying to derive insights out of data? There are a few things that we have to see. One is obviously like the abundance of data that we generate. Okay, let's say, for example, if you interact with any website, let's say, for example, with eBay, as I kind of like said, we can like track, like let's say, for example, what are the pages that the user has logged in, clicked in, and then like what are the various clicks that happens in a given particular site, so on and so forth, right? So based upon all these things, we kind of like tend to make a decision of what we could do with regards to this particular user when it comes to, let's say, like delivering good content or something. And then like the data that we generate, in general are kind of like is of huge volume as well. And then like the variety of data is also so wide. And then like the velocity of data, let's say, for example, at this particular given minute, and positive, there are like millions and billions of requests made on the internet, right? And then like you could see like that in turn kind of like affects the volume, increases the volume. And then like the variety of data is also so huge when it comes to like we have text data, we have like sound data, we have like images, we have videos. You could think of like numerical and categorical data. So you could think of like these many varieties of data with such high volume and such high velocity flowing into the systems. So that's what makes computers a lot more interesting. That's what makes data science a much more exciting stuff in this particular era. And then like the compute, the improvement in compute that we have at this current age is something that has definitely helped in the boom of data science for sure. Storages have become a lot more cheaper. Computers have become a lot more effective when it comes to handling huge data. The CPU memory, those are kind of like pretty efficient these days. And then like with them being able to support like huge volumes of data, I think that makes the difference with regards to this particular era. And then like it's not going to stop here. Okay, like as we could see, like smaller and smaller business are going to start applying data science and machine learning for their own businesses, which will definitely help them improve as well. And then also like the scope of data scientists is going to go keep going up as well. So as a final slide, we have like the key skills for a data scientist. So based on my experience, like for the past 5 6 years, what are the key skills that ideally one should possess for them to be successful in this particular field? Or as follows: one, obviously, like you should have like a good understanding of like your fundamental computer science, let's say programming, and then like algorithms. Like for example, I primarily use Python. In fact, like the general data science community uses Python a lot when it comes to like building models and stuff. So definitely a programming skill, and then like good data structure and algorithm skills is must. And then like the other skill sets are like statistics, trying to understand, okay, what's the difference between like the various tests that you would conduct, how you could conduct a proper hypothesis test, how you could conduct an experimentation. So these are the various skills that you would hone on yourself when it comes to statistics. Okay, and then comes like the machine learning side of things, understanding like what are the different algorithms that we have, how do you hyper tune several algorithms, when to use an algorithm, when to use like another algorithm, what's the bias variance trade-off of different algorithms. So understanding having a core understanding of these things is a must as well. And then like finally few of the other things are like the visualization side of things, and then like how effectively you communicate the skills, communicate the results to the stakeholders. Okay, I think these two kind of like matters a lot as well, because again from my own experience I kind of like meet a lot of people on a day-to-day basis who aren't from the data science side of things. Okay, so they kind of like keep on asking, okay, what is precision or what is recall, how do we interpret this particular result, how do we kind of like make sure this model is the best one that we have in production. So making sure you properly communicate to them kind of like makes a lot of difference as well. So yes, as a core skill set, I think these should be kind of like really good for one to be like a successful data science. So this is just based out of my experience that I'm sharing these things. And then like finally, I just want to quickly show how a machine learning models actually kind of like look like. So it's just like a GitHub that I have. This was being done during my university time. So the idea of this particular project was, okay, you have like certain set of drugs. Okay, so and then like based on these set of drugs, we are just trying to predict is that of an opioid or not. Does this particular doctor prescribe an opioid medicine or not? So that's the whole intent with regards to this particular project. And then like as you could see, we have the data. So we just try to do some pre-processing, let's say in this particular case, dropping drugs that are actually opioid, because we are just trying to use the non-opioid drugs and then like mine patterns to predict if someone is going to predict an opioid drug or not. And then like we just have a few functions to kind of like assess whatever we'll be doing down. Okay, so as a process of like the data processing, so we're just trying to downsample the data so that we don't have like a class imbalance. And then like we're just pre-processing the data. So as kind of like the step that we saw. And then like the next step is more about like the future engineering. Okay, so in this particular case, you could see like 239 columns, right? So which means like we have 239 futures in our particular data set. And then like I'm just applying few techniques for us to like effectively select the futures and like engineer the futures as well. So I'm not going to go over these things. And then you could see once I kind of like do all the processing and stuff from 239, I'm down to like 119. So you could see almost like 100 futures have been dropped just because of doing like proper future engineering techniques. So I haven't even built the machine learning model yet. So, this just helps us to kind of like make sure the final model that we build is kind of like lightweight and runs fast when it comes to like, in production use cases. Okay. So once this particular step is being done, I'm just trying to do like future selection process. Okay, so in this particular case, we use like a chi-square test to really understand, okay, what could be like the top 10 futures or top 20 futures, which would help us achieve like the best model that we have. Again, like, once we can like do these things, we decide on like what are the top futures that we should possess. In this particular case, we should go with all the 119 futures that we have so as to build an effective model is the conclusion that we see. In some other cases, like, 50 futures might have been pretty useful for the model to run successfully. Okay. So then like we just try to do like few of the parameter, hypertuning parameter side of things. Okay. A validation curve is just helps us to understand, okay, how the model is performing on the training data set, as well as like the cross-validation data set. So these are just steps for one to understand, okay, how the models are performing when you kind of like put in like different kind of parameters. Let's say in this case with the decision tree, as you can see, like the depth as it increases, which means like as the rule gets a lot more complex, okay, you could see like the training scores become like higher and higher, which means it's just trying to overfit the data, okay, which we call in like, machine learning. There are like concepts like bias and variance. So that's why you need to really optimize on these parameters for it to be a lot more effective. And then like a learning curve is just trying to understand how much data is good enough for us to successfully build a model. So in case of like the T seller Joseph example that we saw, so he might have collected data for last 1 month or last 3 months, but is it kind of like enough? Okay. Does Joseph need like last 2 years of data for him to come up with a lot more better predictions? Okay, that's the question this particular section tries to answer. With regards to this particular case, how much data is good enough data? Okay, you could see like the x-axis as we could increase the training examples. You could see like the green line, which is like the cross-validation, which evaluates the model. It kind of like increases from 2000 to 8,000. It kept on increasing. And then after 10,000, it just kind of like maintains a straighter line. So which means like we at least kind of like need 10,000 data points for to build this model at a much more good efficiency. So if we have like only 2,000 data points, we might not build an efficient model as when we had like 10,000 data points. That's the understanding with regards to this particular graph. So once you have all these things, you just build the final model. Okay, so once you have the final model in place, you kind of like predict on the test data set that we have. And then like you have like several performance metrics that we should kind of like do in order to successfully understand how the model is being performed on the test data set. Okay, in this case, like we had an accuracy of 75%. And then like there are other key success metrics, let's say like precision recall and F1 score. So, these are like more about like trying to understand with regards to like true positive, false positive. Those are more from the technical side of things. Okay. So, but these are few of the measures that one could do in order to successfully see if a model is kind of like good or not. These are with regards to a supervised classification problem that we saw. And then like finally, we have like an ROC curve, a confusion metric, again to evaluate the model's performance. And then like an extension of the same project that you saw above with regards to like few other algorithms. So, and then I have few references for you guys to do. Let's say, for example, one of the courses that I started with is like the machine learning course by Tom Mitchell. So he's a professor at Carnegie Mellon. I kind of like found some interesting things to take from here when I first begin. So, you might find it pretty interesting as well. And then like a few other AI platforms, let's say like OpenAI or DeepMind or Google Research. So they kind of like solve some pretty interesting problems when it comes to machine learning and AI. So you guys should definitely take a look at these things for you to kind of like get different perspectives and then like to kind of like enter into the world of machine learning and data science. That will definitely, I think, will add value to you. And then like, if you're looking to take this as your career path, I think, those would be kind of like pretty good resources to begin with. So yes, those are the slides from my side. Any thoughts, questions?
Thank you, Mr. Anirudh. That was an amazing keynote, and it was pretty great to see your project that you showed us. And thank you so much for the references that you have provided. I'm sure it will be pretty useful for everyone. And based on what I'm seeing on the YouTube live stream, the audience really loved it and even had a few questions for you. So would you mind answering them?
Yes, go ahead.
Thank you so much. So Brinda Dingra has asked us, is there any mathematical tool or a method to measure the accuracy of these applications?
Yes, definitely. Like, when it comes to like measuring the accuracy, so accuracy itself is kind of like a measure that we have. Let's say, for example, you make a prediction, right? Let's say, for example, is it going to rain tomorrow or not? Okay, you have the weather app in your phone. Okay, and then you see, okay, I see tomorrow it's going to rain. And then tomorrow, when tomorrow happens, you don't see a rain. That means like you'll be like, okay, why the weather app did said like it's going to rain tomorrow, which means it's a mismatch. Okay, so which means it did not predict well. So accuracy is kind of like a measure that we have, and then like few other key measures when it comes to like classification are like precision recall. So let's say, for example, let me go back to the GitHub. So you see this particular section, right? So precision recall and F1 score are kind of like few important measures to see how well the model is performing. Precision is going to be like true positive by false positive. I'll also attach the link to like a wiki page with regards to precision recall so that you could kind of like understand how these things are being measured as well. Okay, so it will help you to understand how a classification problem is being evaluated. And then like when you go to the, like the regression side of things, it's going to be like more of we have like a absolute mean square value and the like RMES root mean square value. So think about when it comes to regression, you're going to predict a numerical value as output, right? Let's say, for example, like during my childhood, when me and my friend, when we go to a like shop or somewhere, we'll just play like we'll just hide the tag and can you predict the price of this particular shirt or not? Let's say like the actual shirt might be like $40. I might say like it's probably $25. So now you see I have an error of like $15, right? So if I kind of like keep on doing this for my data set, for each data point, you have a numerical value and then you have like the predicted value. You just subtract these two and then you have the error rate, right? Sorry, the difference in error. Okay, so now you could kind of like take a mean of all these errors. That could be like a measure to see how well the regression model is. And then there are like few other complex measures as well, like R square, adjusted R square, so as to successfully measure how well the regression model is being built. And then like the same with regards to like unsupervised learning and like reinforcement learning as well. So you have like strong, successful performance measures to evaluate or like metrics to see whether a model is doing well or not.
Another question for you that Gauri has asked us. What part of machine learning piqued your interest such that you chose to pursue it as your career stream? And how do you envision the future of machine learning?
So like for me, with regards to machine learning, like what really inspired me is I think uh, the way I could relate to machine learning. Okay, let's say for example, when I was doing my undergrad, I did it my electrical and electronics engineering. So at that time, I did not have enough introduction to computer science and like machine learning and side of things. In fact, I used to shy away from computer science. I did not like during my first year and second year of my undergrad, but later like I just took a course, and then like it's a course with regards to Python. Once I took the course, I kind of like, I don't know what happened, I fell in love with it. And then like my first work, which is at Mobius, is more with regards to do with like with data processing and stuff, kind of like an data analyst, not like core machine learning stuff. So that's when I started to see the impact that it could make, and then I was reading a lot about it, and then like how the future could be, and then like how well I could relate it as well, like the caveman example that we saw, like the bicycle example. So even myself, like let's say for example, even to let's say for example, if I'm gonna eat an ice cream or not. Okay, so then I started to think about a lot of things, right? Okay, so probably I'm gaining weight recently, so I should not eat an ice cream, but I'm craving ice cream, so should I eat an ice cream or not? So there is that dilemma that keeps on going within you, right? Sometimes, and then suddenly you make a decision. Okay, I'm not going to have whatever happens, or probably sometimes you go and have an ice cream. So when you make this decision, you're just kind of like constantly putting yourself through kind of like a rule engine, right? Should I eat or not? I just had my dinner, so should I have another meal by now? So you see this. So the relatability of machine learning is what kind of like really kept on, like is what make me fell in love with this particular field, and then it is never going to die as well. This particular field, like it never did. So it's right from the caveman time of things, machine learning is there, and then it is there, and then it will be there as well. So the future, I think it's going to be like the immediate future I could see is like a lot more smaller businesses will try to leverage machine learning for their own need and stuff. And then like in the longer term, there's going to be like a lot of automation. Like you see, like the robotic side of things is going to keep on evolving as well. I think we are heading towards like an exciting phase with regards to machine learning. In few years, I think at least in California, we might start seeing a lot more like self-driving cars, and then like medical industry is going to use a lot of machine learning to for diagnosis purposes. And then like businesses, e-commerce businesses, commercial businesses, they're going to take it to a next level as well when it comes to driving things forward.
Another question for you that Abhimanyu has asked us is data science a secondary thing that we learn after learning machine learning, or do they go side by side?
I think it kind of like everything goes hand in hand. I think when you kind of like research about data scientists, you could see a lot of terms, and then like all these terms are kind of like go hand in hand. Like my personal recommendation is don't think about all these things. Okay, so machine learning, a data scientist, everything kind of like comes together. All you need to focus is, okay, you have a problem, how you could kind of like solve that problem. In order to solve that problem, machine learning is one way or like one part of solving that problem. Okay, when you see in industry, let's say if I'm at the traffic engineering team, I can't be doing like the end-to-end side of things, right? We have like specific set of problems to be solved, and then like data science is one part of it that fits to solve the problem. Okay, that's all. And then like machine learning kind of like is part of data science, and data science you could just think of like uh, how you could kind of like make some scientific decision or intellectual decisions out of data is called as data science, and machine learning is part of data science.
All right, so one final question for you that Rakesh Prasannakumar has asked us. Do you have any advice for budding data science or machine learning enthusiasts who are currently in college?
Okay, cool. So my recommendation or my suggestions would be like, just be persistent. Okay, when you begin first, it can be a bit difficult. Let's say for example, when I started in 2014, like when I started as a data analyst, like it was a bit difficult in trying to understand, like even now I still remember, like there were like nights I used to think, really, like can machine do a prediction? Like I could not believe, like that's how I was for a certain period of time. Then as I kind of like kept on learning a lot, then like my master's degree happened, which kind of like really opened a lot of things for me. Okay, so the key advices would be like just keep working hard. There are like a lot of areas to cover. So even in data scientists, you could be like specialized in statistics, and then like you could be like, let's say for example, less of like a software engineer. Few other guys might be like a really good software engineers kind of things, but they might be average when it comes to statistics. So there are like various pick and chooses that you could do. So like try to see what really works for you. As I kind of like previously said, uh, try to be a solution engineer. Okay, you have a problem in hand, you're trying to solve it, and then like you're trying to see how data science is going to help to solve that particular problem. So recommendation would be like just be persistent, just try to learn a few of the skill set that I kind of like put in these slides. So basic understanding of programming, algorithms, statistics, and then like coming to machine learning, visualization techniques, and then like importantly like communication skills as well, so as to kind of like properly convey what to interpret out of the models and stuff. I think these would be kind of like pretty good as a starting point. Try to focus on like the fundamentals of computer science and then like statistics. So from there on, I think you should be good enough to you know um, scale up with regards to data science.
Thank you for sharing your knowledge with us. Everyone who is tuned in for today's talk, go check out our Instagram handle where you can find a short quiz based on what Mr. Anirudh has given us today on his keynote. Show us at CSI VITU where you have what you have understood from today's keynote. And while you're at that, take part in our social challenges to stand a chance to win exciting goodies and prizes that you don't want to miss out on. Once again, I would like to thank Mr. Anirudh Muralidhar for considering us and giving us his time. And I would also like to thank every participant who were part of today's keynote. Thank you. Um, Participants, please do note that at 7:30 p.m. today, we will be having our closing